kinematics of uniform circular motion are the same kinematics that we have been talking about. We have distance, we have time, we have speed or velocity, we have acceleration to think about. And some important equations for us are one is for the period, which is the time it takes for one revolution around the circle, which is equal to the inverse of the frequency, which would be in revolutions per second. And so the period is in seconds. And then we have the equation for velocity, which is velocity is distance over time. So in our case, we have 2 pi r, which is the circumference of the circle, over our period, which we're using for time. And then to find the magnitude of acceleration, we have the velocity of the object and the radius of the circle to consider. And this equation is the same as if you used 4 pi squared times r over the period squared. Okay, so those are our equations for the kinematics of uniform circular motion. So let's do some problem solving. An audio CD has a diameter of 0.12 meters and spins at a frequency of 9 revolutions per second. At this rate, how much time is required for one revolution? If a speck of dust is riding on the outside edge, how fast is it moving? What's the acceleration? Okay, so first let's find the time it takes for one period. I have some of our equations down here, so I know that the time it takes for one period is the inverse of the frequency, which is equal to, in this case, we have 9 revolutions per second, and that is going to be equal to 0.11 seconds. That's our period. That's the time it takes to go around the circle once. And then using that, and knowing that the speck of dust is moving around the circle whose radius, which is half of the diameter, is 0.06 meters. And so now we can problem solve, or we can solve for the velocity of this. We're going to use 2 pi r over our period, and we have 2 pi times the radius over our 0.11 seconds. And for speed of this speck of dust that's riding on the edge of this circle is 3.4 meters per second. And then once we have the velocity of this speck of dust, we can find its acceleration. So we'll use this equation, and we have 3.4 meters per second for the velocity. We square that, and then our radius is 0.06 meters still, and we should get 193 meters per second squared for our centripetal acceleration is what we're finding here. So that is a good example of a kinematics equation for circles where you have your time, you have your speed, and you have your acceleration, and you need to solve for all or one of those things when given some other parameters.